Hey guys, I want to talk to you really quickly about the remainder and factor theorems and what you're going to see today. So what you're supposed to do is they'll give you a function, f of x equals x cubed minus x squared minus 4x plus 4, and then there will be a semicolon, and then they'll give you something like x minus 3. So what you're supposed to do with that information is you're going to use synthetic division to see if the remainder is 0 after that division. If it is, then the answer is a yes, it is a factor. And if the division is not, the remainder is not 0, then the answer would be no, it isn't a factor. So I'm going to take this. I'll bring my camera back a little bit. All right, so I'm going to set this equal to 0 and use a positive 3 in my synthetic division setup. So I'll use 1, -1, -4, and positive 4. Drop the 1. 3 times 1 is 3. -1 plus 3 is 2. 3 times 2 is 6. -4 plus 6 is 2. And 3 times 2 is 6. And 4 plus 6 is 10. So right here, this is your remainder, which tells me, so it's going to say yes, it is a factor, or no, it is not. So we would check no for this particular example because the remainder is not 0. So I'm going to show you an example where the answer would have been yes. Okay, so again, I'm going to be doing that synthetic division. I'm going to set this equal to 0 and solve. So I'm going to use a -2 over here. 1, 2, -1, -2. Drop the 1. -2 times 1 is -2. 2 minus 2 is 0. -2 times 0 is 0. -1 plus 0 is -1. -2 times -1 is positive 2, and -2 plus 2 is 0. So since the remainder is 0, that means that yes, x plus 2 is a factor of that original polynomial. And I would be able to factor the rest of this if I set it up, but that's not what they're asking me to do, so I'm going to go ahead and move on to the next problem. So that is the remainder theorem. Okay, the next set of instructions is going to be different. It'll say factor completely given a factor. So the fact that they say given is very important. It tells you that when you do your synthetic division, you should get a 0 as the remainder because this is a factor. That's all the yes and no stuff we were just doing. So I'm going to set this equal to 0 and use a -5 in my synthetic division. So -5 times 1 is -5. -5 minus 5, -10. Negative 5 times 10 is 50. I think 29. Negative 29 plus 50 is going to be 21. And then negative 5 times 21 is negative 105. When they tell you that this is given and you don't get a 0 as the remainder, that means you've made a mistake in your math somewhere that you really need to go back and figure out what happened, because it should be a 0. So now what they're asking you to do after you've done this step is to factor this answer. Well, we can't factor it until we put the x's back in. Remember, this was x to the third. This means that this is now 1x squared minus 10x plus 21. So I'm going to look for factors of a positive 21 that combine or add to a negative 10. So that'll be 7 times 3. They're both negative. So I've got x minus 7, x minus 3. So that's part of my answer, but I also want to include that original x plus 5 that we factored out from the beginning. That also goes in my answer. Notice the original problem was x to the third, or had 3 x's. So I want to have 1, 2, 3 x's in my answer. So this is completely factored. All right, hope that's going well.